So what we've got at the moment is just to demonstrate the battery in discharge mode. It's still early in the morning, the sun has just come online with the solar, so we're getting about 12.6 kilowatts. The plant at the moment is drawing about 14, and we are actually supplementing from the battery because the plant's drawing more than the solar is providing. What we do, if you look here, you'll see supplementation from the grid, and right now the solar just kicked up, and so there's excess solar and the battery's automatically started charging. So that's this battery's job in this situation is to absorb all the excess solar during the day and give it back during the peak period. It's between 5 p.m. and 9 p.m. every day. That's the peak tariff, and so all the excess that they couldn't use in the day, they're using at night to offset that cost. The other thing that the batteries are doing is they are stabilizing the voltage control of the inverter. When you've got clouds coming overhead, you see the PV array going up and down quite dynamically, and the inverter is using the battery as a buffer. That's what we saw just now, just supplementing from there. But when the sunshine is solid, like it is now, we're getting a nice little burst. The solar is feeding the plant, and excess is topping off the batteries.
Very cool.
Okay, so as it stands, right now the plant is in a very low demand mode, but the plant picks up to 60 kilowatts fully when it's in full swing.
This is a 60 kilowatt solar converter that we have here, three phase?
That's correct.
Okay,
and
very good.
It's not the whole plant. This is one section of the plant that's dedicated to supplementation. It's the most critical part, that they don't want power interruptions, and it's very critical for them that they don't use lighting or heating or anything like that.
Cool. Take us through the back of the battery here, or I should say the energy storage.
Here we have the controller, the high voltage controller. Here we have the inverter connection, and then there's the battery connection. So these are inputs here to tie into the fire system, as well as the mandatory external disconnect. So the fire department needs to be able to come and kill everything. Those signals come in through the back here and shut everything down. On the front, these fuses here are so that we can actually isolate the battery independently from the inverter. And if you isolate both, the controller doesn't have power. There's an auxiliary power at the back so that you can do servicing with both of these disconnected.
Is there a generator at this facility?
There is a generator, and the inverter is actually the arbitrator of whether we go to solar, generator,
grid, whatever.
Batteries,
whatever.
So,
very good.
Then here we can just have a look at the state at the moment. We see that the system is healthy. The main contactor is closed. There's actually triple redundancy on isolating the high voltage of the batteries and the inverter. There's a main contactor, and then there's two separate contactors for charging and discharging. So everything is healthy right now. All of that is enabled. This system itself, this fuse carriage, that fuse carriage, the terminals at the back, the contactors, the bus bars, everything has its own temperature sensor. And you can see there, as we started having some power flowing through when the sun came online, and also just as the environment warmed up, we had a slight heating on those buses. But if you should have a dry joint or a bad connection, this is going to pick up immediately if there's any service required.
This module itself, the blue module, is referred to as what?
That's the controller.
That controller.
The high voltage controller.
All right, very good. And that's what's being fed directly by the solar.
That's correct.
All right, very
that's
good.
Right, yeah. So then we also have the individual cell voltages coming through. There's a little bit of quantization noise on there. The signals are all quite zoomed in.
I think you said 13 of the energy storage modules that you have?
That's correct, yeah.
Very good.
So what you can see is that the cell voltages are trending up. What I'll do is I'll just go to the overview. So right now, because we've just got marginal excess and shortage on the solar, we've just got a very small charging and draw current that's going on there.
Okay. Very good.